So electrolysis, it's basically used to separate ionic compounds. What are ionic compounds? So we looked at ionic compounds in a live 2 weeks ago between a metal and a non-metal. So the ionic compound that you're separating is in the liquid itself. This liquid, anyone know what the name of this liquid is in electrolysis? So this is relevant for OCR, Edexcel, and AQA. Electrolyte, thank you, Olivia. So we call that the electrolyte. The electrolyte is the ionic compound. And it's an ionic compound that's either molten or aqueous. Molten just means it's melted to a liquid. Aqueous means it's been dissolved in water. Okay, so knowing which one you're dealing with is really important in electrolysis because it determines what products you get. So you have your ions. So your electrolyte is going to always have a positive ion and a negative ion. So in this liquid here, you're going to have both floating around. You're going to have millions of positive ions, millions of negative ions as well. And you have two electrodes here. One's the positive one, one's the negative one. So that's why we have panic to remember which one's which. So positive is for the anode. That's one of the electrodes. The positive one's called the anode. And the negative one is cathode. Usually they'll give you the charges on each, but if you don't know, if you're just given a diagram like this and asked to figure it out, look at the battery. Okay, so on the battery or the cell, the longer line is always the positive one and the shorter line is always the negative one. Because in a battery, if you look at a battery, you always have a positive side and a negative side. The longer line always represents the positive one and the shorter line always represents the negative side. So the electrode that's connected to the positive side, that is your positive electrode, which we just called our anode. So that one's going to be the anode. And the negative one is connected to the negative side of the cell. That's the cathode. So what happens during this process? So you connect the circuit up, you put your electrodes into the solution, and you're going to get movement of the ions. So the positive ion is going to get attracted to the cathode here. So it's going to move there, and the negative ion is going to get attracted to the positive electrode because opposite charges attract. So two types of reactions that happen. You have a reaction at the anode and a reaction at the cathode. So when the negative ion goes to the anode, so let's write this down here. So at the anode, at the cathode, two different things happen. So at the anode, you have an oxidation reaction. So that's what this is here for. ORAC, basically, if you want to remember it. Oxidation happens at anode. Reduction happens at the cathode. Okay, oxidation. What's the difference between oxidation and reduction? That's what oil rig's there for. So oil rig, oxidation basically means the loss of electrons. And reduction is the, why did I put oil rig? That doesn't make sense. Oil rig is the gain of electrons. Yeah, thank you guys. So at the anode, we have oxidation. So that means when this negative ion goes to its anode, it gets oxidized and it loses electrons. And at the cathode, reduction happens, which means it gains electrons. And at both of these electrodes, the same thing always happens. You always go from an ion to an atom. No matter whether it's positive or it's negative, you start off with an ion and you end up with an atom. So at the anode, you oxidize the negative ion to become an atom. Cathode, you reduce the positive ion to become an atom. So the end goal is always to get an atom. Okay, so we'll come back to this and we'll use it in some of these questions, and hopefully it'll make more sense as we do more questions. So on to the first question. I think the first question's on, it's acids and bases. I'm going to go through the acids and bases ones quite quickly. I'm going to focus on electrolysis the most. So give the color change when nitric acid is added to a mixture of universal indicator. So what color would an acid be when you add it to universal indicator? What's the color change going to be? What do you guys think? I will give you a chance to screenshot that first page at the end once I've finished all the notes. Not blue to red, because it's nitric acid is being added to water. So at the start, you have water and universal indicator. So water is neutral. Nitric acid is acidic. So it's going from neutral to acidic. What color is neutral? Neutral is green. Yep. And then acidic is red. So the answer is going to be green to red. Good. Next question. What happens to the pH of water when nitric acid is added? So pH decreases. People sometimes make the mistake of thinking increases, but pH is the number. The lower the pH, the more acidic it is. pH 1 is acidic, pH 14 is alkali. So when you're adding nitric acid, it's going to become more acidic, so it's going to decrease. These questions are both for higher and foundation. What is the state symbol for nitric acid? What do you guys think? Aqueous, yes. Aqueous, not liquid. AQ, you can get away with just saying AQ brackets. You can write aqueous as well. Actually, no, it asks for the state symbol. You have to write AQ. Not liquid. Any acid is always aqueous because it's a solution. If something's a solution, then it's aqueous. All right, on to the next one. Zinc carbonate reacts with nitric acid. Carbonate plus acid forms salt plus water plus carbon dioxide. That's one that you need to memorize. So carbonate plus acid goes to salt plus water plus carbon dioxide. What would we observe then if we were to do this in real life in a lab? Fizzing, good. You'd see fizzing. Whenever there's a gas released, so there's carbon dioxide released from a liquid or two liquids, you'll see fizzing or bubbles. Those are both the same mark. What's the second mark for? Heat release, not necessarily heat released. That's not observation. You can't see that. You can't see heat release. No color change. Nope. Imagine this, guys. You've got an acid, you're putting a solid in it. What happens to the solid? No flame. So you get bubbling, and what will happen to the solid? Yeah, it gets smaller, doesn't it? If you put something in acid, the solid gets smaller. So you can say solid disappears. Disappears. You can also say solid is left at the end because it says here the carbonate is in excess. So you can say that as well. Saying excess zinc, you don't get a mark for saying excess zinc. It says zinc carbonate is in excess. So you say the initial solid disappears, but eventually you'll have solid left over because it's in excess. If something's in excess, it means you have more than enough of it. Okay, next one. The formula for zinc ion is Zn2+. The formula for nitrate ion is NO3-. What's the formula for zinc nitrate? Do you guys remember the method of working it out? Charges swap. Yes, we did this in another live. So we got 1- charge here. We have a 2+ here. So what you do is you swap the numbers around. So the Zn gets the 1 and the NO3 gets the 2. But it already has a 3, so what you need to do is put a bracket around and put a 2 here. And you don't write 1s, so you cross that out. So what you've got is Zn NO3 2. That's the answer. Yeah, so I hope you guys understand that method. If you don't, it is on my YouTube. I have a video on this on YouTube. Is this one here? Is a print and practice one. Write any chemical formula, loads of examples, and I basically go through this method for loads of different examples and give you the list of all the ions you need to remember. So yeah, the YouTube is Flash Revision Lab if you guys want to try that out. Right, back to the questions. Right, we've got electrolysis now. Hydrogen gas and chlorine gas are produced when sodium chloride solution is electrolyzed. Hydrogen ions are attracted to the negative electrode, so that's the cathode. Half equation is this. Okay, so half equation is this at the negative electrode. What type of reaction happens? Right, so this is a cathode. What reaction happens at the cathode? Someone remind me. We have it in our notes up here. At the cathode, we have reduction. Well done, guys. It's reduction. Remember, at the cathode is reduction. Oh, a rack. To remember that. Oxidation's at the anode. And then the second part of the question basically asks what happens at reduction. So in reduction, you have gain of electrons. Those are your 2 marks. So type of reaction, reduction. Reason for it. So look at the half equation. You're starting off with H+. You're adding electrons. It's plus E- to form an atom. Remember what I said at the start? I said it always goes from an ion to an atom. All half equations do that. So on the left-hand side, you should always have the ion. On the right-hand side, you should always have the atom or atoms. Electrons, which side it's on depends on whether it's reduction or oxidation. If it's a reduction reaction, the electrons are going to be on the left-hand side. If it's an oxidation reaction, electrons will be on the right-hand side. So how do we know it's reduction? Because it's gaining electrons. Gained. This is triple and combined. This can come up for both triple and combined, guys. All right, complete the half equation for chlorine. So half equations, the way to do half equations is, first of all, remember for reduction, electrons are on the left. Let's add that to our... So for reduction here, electrons on the left-hand side. And here, electrons on the right. So when I say that, I'm talking about the half equations. Okay, so when you do half equations, this is what I want you guys to remember. First thing, you always need to have the ions on the left, atoms on the right. Then electrons, if it's the anode equation, it's going to be on the right. If it's the cathode equation, it's going to be on the left. So what do we have here? We have positive electrode, so that's anode. That means our electrons are going to be on the right. That's why we've got two lines here. So one of these are going to be the electrons. What's the thing here? What's missing here? What do you guys think? Cl2. Good. Why is it Cl2? Why is it not Cl? Why is it Cl2 and why is it? It's diatomic. Yes, Cl2 is diatomic. So what? Let me tell you guys. Everything that's diatomic. So diatomic elements. What we have: hydrogen, nitrogen, oxygen, and all of group 7. Okay, all of these are diatomic at room temperature. Those are the ones that will come up in your GCSEs. So here, that's why Cl is Cl2. We've got Cl minus here, so all we need to do now is balance this. So we need a 2. Anything else we need to do here, guys? 2 atoms here. Yep, is that done? Or do we have more to do? What does diatomic mean? Diatomic just means it has that 2 in it. It exists as 2 atoms because it makes it more stable. So 2 atoms in a molecule. So one molecule of chlorine has 2 chlorine atoms in it. That's what diatomic means. There's just some which are diatomic. You just need to memorize them, basically. 2 electrons. Good. Well done for those of you who spotted that. It needs to be balanced, guys. Each chlorine atom loses 1 electron. So if you have 2 chlorine atoms, you're going to lose 2 electrons. That's why. All right. Next question. Hydrogen gas and oxygen gas are produced when sodium sulfate solution is electrolyzed. Explain how oxygen gas is produced in electrolysis. Right. This bit, you guys got to keep up with me here because this is the bit where people get confused. So let me go through this. You can have 2 different types of electrolysis. The easier one is molten electrolytes. The trickier one is when you have aqueous electrolytes or electrolytes in solution. So whenever you're looking at an electrolysis question, first try and see whether it's molten or aqueous. If it's molten, it's straightforward. For example, if you had sodium chloride as your electrolyte and it was molten, so it's liquid, inside your solution, inside your electrolyte here, you see here we have a positive and a negative ion. You would just have the elements that the compound has. So the ions would just be Na plus and Cl minus. If you have an aqueous electrolyte, so let's say we have sodium chloride, aqueous, you have additional ions. So you would have Na plus, that's just splitting up the Na plus and Cl minus, but you'll also have two more ions. Does anyone know what they are? Thank you for the gifts, guys. Hydrogen and OH minus. Good. H plus ions and OH minus ions. So whenever you have an aqueous electrolyte, on top of your two ions, you also have H plus and OH minus. All right. So that means one of these positive ones will move to the cathode and one of the negative ones will move to the anode. You got to figure out which one it is, but we'll talk about that later. Let's go to our question. Explain how oxygen gas is produced in the electrolysis of sodium sulfate solution. Sodium sulfate solution. Can anyone tell me what the ions that are going to be in sodium sulfate solution? It's solution, so that means it's one of the aqueous examples. So there should be 1, 2, 3, 4 ions. Solution has an OH and H plus, good. Na plus and SO4 close, 2 minus. Okay, so sodium sulfate is this. Okay, so the ions present in Na2SO4 is sodium, sulfate, which is SO4 2 minus, but it's a solution, so that means just like I just said up there, we also have H plus and OH minus. So it's asking you, the questions are asking how is oxygen gas produced? Where does that oxygen gas come from? What do you guys think? Yep, solution means aqueous. If they say solution, that's what should be in your head. It means aqueous, not molten. Yes. You got to figure out whether it's a halide ion or not. Okay, so remember what we said. We have our two electrodes. In our solution, in our previous diagram, we only had 2 ions. This time, we have 4 ions. We have Na plus, we have H plus, we have SO4 2 minus, and we have OH minus. Only one of the positive ones can go, only one of the negative ones can go. And you need to figure out which one it is. So out of the positive ones, how do you decide which one goes? Which one is going to go to the negative electrode? Close. It's not which one's more reactive. It's the least reactive one goes. So for the positive one, it's the least reactive ones that go. So out of Na plus and H plus, which one's least reactive? This question is AQA. Yes, it is. H. Good. So this is why you need to know the periodic table pretty well. So it's going to be the H plus that goes. So the rule for the positive one is the less reactive one goes. What about for the negative ones? Which one? What's the rule for the negative ones? I think people said it earlier. Okay, it's to do with halogens. Okay, so for the negative one, guys, this is the rule. If there's a halogen present, halogen means a group 7. If there's a halogen present, the halogen will go. If the halogen is not present, then OH minus will go. So here, do we have a halogen? In SO4 2 minus, do we have a halogen? No, we don't. So that means the OH minus will go. Okay, so let me write this down in our notes. So this is all to do, remember, only to do with aqueous ones in solution. If it says in solution or it says aqueous electrolyte, then that's when you start using the rules. So the rules for the positive ions is the less reactive ion will go to the cathode. And then for the negative one, do I have space? I'm going to have to make it work. If a halogen is present, it will go. If not, the OH minus will go. All right. I'll give you guys a chance to screenshot this at the end. So back to the question. No, I think we've got a few more questions on acids and bases as well. Do I have to remember the half equations at the cathode and anode for molten and aqueous state? You don't need to memorize the half equations. You need to figure it out. You need to be able to figure it out. The only one you need to memorize, I wrote it up here. This is the only half equation I would say you need to memorize, is the one for OH minus. Because remember here we wrote, if a halogen is not present, if a halogen is present, it will go. If a halogen is not present, the OH minus will go. If the OH minus goes, then this would be the half equation. So this one you need to memorize. Everything else you can figure out by doing the method of doing ion on the left, atom on the right, electrons on the right if it's anode, electrons on the left if it's cathode. So what we did, what did we have? For our example, we had Na plus, we had SO4 2 minus, we had OH minus, and we had H plus for that question, isn't it? So Na plus, H plus, it's always the less reactive one that goes. So here we got our reactivity series. This is why it's important to remember the reactivity series. That's why I put a line on H. These are the only 3 that are less reactive than H. So if you would just want to memorize that, it might be easier. It's useful to know the whole reactivity series, but the only ones that are less reactive than hydrogen are copper, silver, and gold. So So if you want to memorize that, just think of like the Olympic medals. You have a gold medal, you have a silver medal, and you have a bronze medal, which kind of looks like copper. That's one way you can memorize it. If you have any of those three, those are less reactive than hydrogen. All the other metals, pretty much the ones that you'll come across, are more reactive than hydrogen. Yes, I do have a mnemonic for the reactivity series. Check out the video that we posted last week. It's on the page. There is one last week. Okay, so explain how oxygen gas is produced in the electrolysis of sodium sulfate solution. So you need to talk about oxygen being made here from the OH minus. Where does that come from? It comes from water. Because it's in solution, the water breaks down to form H plus and OH minus. So you get a mark for saying water forms H plus and OH minus ions. That's 2 marks. And then you say the OH minus ions are attracted to the anode. And then, like we said, at the anode, we have oxidation. So OH minus ions are oxidized to form oxygen. Okay, any questions on this, guys? Okay. Right, let's move on. When is oxygen not produced? When if this went, that would have produced oxygen. Oxygen only really gets produced if it's an O2 minus ion that's going or OH minus ion that's going. Those are the only two that produce oxygen. Why is it oxidized? Because it's happening at the anode. You always have oxidation at the anode. You always have reduction at the cathode. Yeah, if it's not halide ion, oxygen is produced. Exactly, because the OH minus goes. This is the reaction that's happening, guys. At the anode, the OH minus ion goes, and look here, there's oxygen here. There's also water produced, but you don't really see that because it's a solution. The water just goes into the solution, so you don't really see it. What is a halide ion? A halide ion is just a group 7. Anything in group 7. So chlorine, fluorine, bromine, iodine. Yeah. Do you not get a mark for saying no halide ions present? No, because the question's asking explain how oxygen gas is produced. It's asking more about the formation of it rather than why it's produced. If it asked why, then yeah, you would say because no halide ion is present. But how is basically asking where is it coming from. Okay, let's move on. Right, this one I'm not going to spend too much time on because I have a full video on ionic covalent and metallic bonding on YouTube. So this is just saying, describe in terms of electrons what happens when magnesium atom reacts with chlorine to produce magnesium chloride. For 4 marks, magnesium chloride. So you got Mg2 plus, you got Cl minus. So you would say magnesium loses 2 electrons. How do we know that? Because it's Mg2 plus. Chlorine gains 1 electron. How do we know that? Because it's got a charge of -1. And then if we do that method that I showed you earlier again, if we get the Mg2 plus and the Cl minus and then swap the charges, you'll find out that the formula for magnesium chloride is Mg1, but we don't write the 1, Cl2, because that 2 comes on the other side. So that means you have 1 magnesium and you have 2 chlorines. So you get a mark for saying that. So 1 magnesium and 2 chlorines present. You can write in bullet points in exams, guys. And then we've got 1 more mark here. So we've got 3 out of the 4. What type of bond do we have here? This is a metal. This is a non-metal. So what kind of bond do we have? How do you get 1 magnesium from 2? The 2 is telling you the charge. It's not telling you the number of magnesiums. That's how many electrons it's lost. It's not how many magnesiums there are. It's ionic, guys. It's not covalent. Ionic bond formed. The reason we know that, metal, non-metal forms ionic. If it was a non-metal and a non-metal, that would be covalent. If it's a metal and a metal, it's metallic. So like I said, guys, we have on YouTube the live that we did for bonding, where we did questions on this. So check that out if you're still confused about this stuff. And this bit as well, that's on YouTube as well. That's this one here, how to write any chemical formula. We've got loads of examples practicing that. So go on to that if you want to practice that method. And then bonding, watch that. You can print off the sheet and you can do it with the video as well. Right, look at this. We got magnesium chloride can be electrolyzed. 2 experiments. Look at the difference here. It's the electrolyte. Both of them are magnesium chloride, but this one's molten. This one's dissolved in water. So this one's aqueous, solution. And this one is molten. That's the first thing to identify. That's the difference. So we need to think about the 2 different tables, the 2 different columns in the table that we had. What does aqueous mean? Aqueous means dissolved in water. If you get salt and you put it in water and it dissolves, you have a salt solution. It's aqueous, it's dissolved in water. All acids are also aqueous. Okay, explain why magnesium chloride must be molten or dissolved in water to be electrolyzed. This is a bonding question. What do you guys think? Why does it need to be molten or dissolved in water to be electrolyzed? Right. So, yes. Careful, some of you have fallen into the trap. It's not to do with electrons. It's all to do with ions. In GCSE Chemistry, you're going to come across only 3 things that conduct electricity. Ionic compounds, which are molten or dissolved in water. Graphite. And metals. So loads of people make this mistake. They think the reason ionic compounds conduct electricity is because of electrons. That's not the case. It's because ions are free to move. Graphite and metals, these ones are because electrons are free to move. They have delocalized electrons. So don't get the 2 confused. Yeah, you don't really say delocalized ions, you just say free moving ions. So you say because ions are free to move, that's 1 mark. This is a 2-mark question. The second mark is to say that because they're free to move, it can carry a charge. So it can, or we'll say they can carry a charge. Yeah. Don't say so it can actually no, you can say, I wouldn't say conduct electricity. Yeah, say carry a charge. Don't say because they can conduct electricity. This question's basically asking why can it conduct electricity. So try and word it like this. Okay, explain how magnesium is produced at the negative electrode in experiment 1. Experiment 1 is molten magnesium chloride. What are the ions we have here? Well, we've actually got it here, don't we? The 2 ions. We have Mg2 plus Cl minus. This is molten, so that means it's only got Mg2 plus and Cl minus. No H plus, no OH minus. This side, this is aqueous, so it has Mg2 plus, Cl minus, but it also has H plus and OH minus. Okay, we'll forget about that for now. This question is only asking about molten. It's saying, how is magnesium produced for 3 marks? What do you guys think? What can we say? Not oxidation. It's reduction, remember. Negative ions is talking about magnesium, so it's actually talking about positive ions, Mg2 plus. So we need to talk about positive ions. Positive ions gain electrons. Yeah. Are attracted to the positive ions. Reduction needs to gain 2 electrons. Okay, good. So let me tell you, we got a positive ion. Let's look back at our notes. Positive ion, that's being attracted to the cathode. At the cathode, you have reduction. Reduction is the gain of electrons. So you need to mention that the positive ion is going to gain electrons. And how many electrons is it going to gain? How many electrons does magnesium need to gain to become an atom? Remember, it needs to go from being an ion to an atom. It needs to, yeah, Grace, well done. It needs to gain 2 electrons. Perfect. So we get a mark for that. We get a mark for saying it gains electrons. Second mark is to say it gains 2 electrons. The third mark, which should actually be the first mark, is to basically just say that it's attracted to the negative electrode. So first mark is to say the Mg2 plus ions are attracted to the, which one is a negative cathode? So magnesium gains 2 electrons. You can say reduced as well, but you have to mention that it's 2 electrons. So that's the first mark. This is the second mark to say gains. Third mark is to say 2 electrons. Yeah, it's in group 2, so it has 2 outer shell electrons. That's why it's 2 plus. Hope that made sense. Next one. In experiment 2, this time is the aqueous one. a gas is produced at the negative electrode. Name the gas produced. Right. At the negative electrode, which gas is it? Which gas is going to be produced? So you need to decide out of these ones, which one's going to go. So on the positive side, guys, which one's going to go? And on the negative side, which one's going to go? Remember the rules. So positive one, the less reactive one goes. Negative one, if there's a halogen, that will go. If a halogen's not present, OH minus will go. Hydrogen, well done, guys. Hydrogen is less reactive than magnesium. Remember, only copper, silver, and gold are less reactive than hydrogen. On the right-hand side, what would it be? Would it be OH minus or Cl minus? I know the question is not asking, but I think it comes later. It's not OH minus, it's Cl minus. Remember the rule. The rule for the negative ones is if there's a halogen present, the halogen will go. Chlorine is a halogen. It's group 7. So Cl minus will go. The other experiment that we did, the other question we did, it was sulfate. So there wasn't a halogen present. That's why OH minus went. But this does have a halogen. So Cl minus goes. So it would be Cl minus. So this question asks, what's the gas produced? So if H plus ion goes, what gas is produced? What would we say? So saying H plus would not get you the mark here because that's the ion. It's asking about the product after the electrons has been gained. Hydrogen gas, exactly. So you'd say hydrogen. Just as an extra part, guys, I'm just going to show you how to do the half equation here. So remember, ion goes to atom. All right, so write the ion on the left-hand side. Write the atom on the right-hand side, H. But H is one of the ones that we saw that was diatomic. Remember the diatomic ones, H2, see there? So we have to write H2. Then we add our electrons. Which side do the electrons go on? Do they go to the left or do they go to the right? This is happening at a cathode. So it's going to go to on the left. So we add electrons here. And now we need to balance. So we have 2 hydrogens here, H2. So we need to have 2 hydrogens here. So we put 2H plus. And then because you have 2 H pluses, you need 2 electrons to make 2 hydrogen atoms. So that will be the half equation there. The question's not asking, but yeah, I just wanted to show you guys that because I know people struggle with writing half equations. Suggest why magnesium is not produced at the negative electrode for 1 mark. So it's basically asking, why is it H plus? Why is it not magnesium? So it's the rule. What do we say for 1 mark? Because magnesium is more reactive, exactly. Excellent. How do we know where the electrons go? This is how. At the anode, so the one with the, so anodes are positive, so this is the one with the negative ion. So if it's a negative ion, electrons are going to go on the right. If it's a positive ion, so that one was H plus, I think, the one that I did. Yeah, because it was H plus, it goes on the left. So I'll give you guys a chance to screenshot all of this and then you'll work it out. What does magnesium react to? I'm not sure what that means. Mg2 plus reacts to form magnesium metal, so the atoms. Complete and balance the half equation for the reaction at the positive electrode. So remember what we said? We said Cl minus will go. So this question is basically asking to write the half equation for Cl minus. So let's try this without actually looking at that question. Let's follow our rules. So we're going from ion to atom. So everyone watch this carefully. So ion on the left, Cl minus, arrow atom on the right, Cl. Chlorine is diatomic. It was on the list of diatomic elements that I talked to you about because that was a halogen. It was a group 7 element. So we put a 2 here. Electrons, do they go on the left or do they go on the right? So what did we say up here? We said if you're dealing with a negative, then it's going to go on the right. Negative ion, it's going to go on the right. So we put the electron on the right. Now we have to balance everything out. We've got 2 chlorines here. We need 2 chlorines here. And if we have 2 chlorines losing 1 electron each, we have 2 electrons that are being lost. So that's the half equation there. Hope that made sense. So let's add that here. So we got 2 Cl minus here. It goes to CO2 plus 2E minus. Okay, this is a question on just bonding, I guess. Explain why metals can be bent and shaped. Just for 2 marks, anyone know? Yes, you do need to know what atoms are diatomic. So right at the end, guys, in a few minutes time, I'm going to let you screenshot that sheet. It's got everything that you need to know that's diatomic. Good. Hasana, thank you. They have layers that can slide over each other. So they have layers that can slide over each other. So 1 mark to mention the layers and the other mark to mention the fact that they can slide over each other. Yeah, that would be 2 marks. So 1 mark for that and 1 mark for this. Not lattice structure. They do have lattice structure, but that doesn't explain why they're bent and shaped. Not intermolecular forces. Intermolecular forces only happens for molecular substances, so covalent ones. If you want to, we have a live on bonding on YouTube, so you can go and take a look at that. I explain all those differences in that, so you can basically tell the difference. Alloys, yeah, alloys is difficult to shape because the layers get disrupted, so you can't really slide them over each other. Malleable, yes, this all means malleable. Bent and easily shaped basically means it's malleable. Distorted layers, exactly, you're distorting the layers. They're not molecular substances. State symbol for ammonium nitrate solution. What do you guys think? No, malleable will not get the mark there because it already basically tells you that it's malleable. It can be bent and shaped is basically them telling you it's malleable. So you wouldn't get a mark for saying that. Aqueous, yes. Rambate's asking for state symbol, so just write AQ, don't write aqueous. What is the formula for nitric acid? This is one you need to memorize. This is higher combined, these questions. So it's relevant to triple and combined, this question here. HNO3, yep, this is one to memorize, guys. HNO3 is nitric acid. Another one is sulfuric acid is H2SO4. HCl is hydrochloric acid. Yeah, those are the main ones you come across. Ammonia gas dissolves in water to produce ammonia solution. Ammonia solution contains hydroxide ions. If it contains hydroxide ions, what does that tell us about it? So they add universal indicator. Nitric acid and ammonia, what color is observed in each one? So if it's hydroxide ions, what does that tell us? It's alkali. Exactly. So what color would we see with universal indicator for each one? So top one and bottom one. So top one is an acid. For the top one, you'll see red. This is an alkali because it's releasing OH minus ions. So that's going to be blue. Red, because it's an acid. Acids in universal indicator are red. So acids are red. If it's neutral, so if it's water, it's going to be green. And if it's alkali, it's going to be blue/purple. Universal indicator. And here, yeah, we know it's alkali because alkalis always release OH- ions. Acids release H+ ions. So that's how we know the difference. Yeah, blue or purple, either one's fine. You can say blue or purple. They're both on that side of the spectrum. Well done, guys. Right, let me show you guys the notes. You can screenshot it. And as usual, I will put this video up this week at some point. The whole live, I'll put it up on YouTube.